All right, welcome everyone. Happy New Year's. Hope everyone had a good New Year's Eve and has a good day today. We're gonna get started with day four of our winter boot camp. Um, just if you guys need a refresher, my name is Yuhane. I'm the co-VP for the activities division for SLB, and we have another presenter today. Felix, do you want to introduce yourself?
Yeah, hi everyone. My name is Felix. I am also an ACSEF alumni. I graduated in 2024 and I'm currently a sophomore at UC Berkeley. I'm studying economics and data science, but my own science fair journey took me to ISEF in 2022, and I was also super honored to be a Regeneron STS scholar in 2024. ISEF was really such a pivotal part of my growth. And I'm super thrilled to work alongside the super inspiring SLB team to help you all navigate your projects. Yeah.
Yep. Yeah, thank you, Felix. So yeah, obviously Felix is very experienced with the ACEF pipeline. So if you have any questions about anything related to ACEF or just college related in general, you can feel free to ask Felix. But we can get started now. So today's day four of our boot camp, and today's main focus is going to be on data analysis and the conclusion. So the first 3 days, we're just setting up your procedures, setting up your methodology, kind of finalizing your research question. And today we're going to explore how to visualize and collect your data and analyze that data as well. So we'll be showing different techniques to do that. And then we'll also be showing a good structure for the conclusion, which is something that a lot of students get mixed up on. So we're gonna introduce that as well today. So today's, I guess, a more specific overview. We're going to be first starting off with data collection and the different types of graphs. So obviously there's a lot of different types of graphs. We're going to try to cover like the most common graphs that we see on science fair projects and introduce them so that everyone's familiar with how to use them, how to apply them, and how to create them. And then yeah, then we're gonna go into how to actually create these graphs. So we're gonna be using Google Sheets for that. So if everyone does have a Google account, please try to sign into Google Sheets right now so we can get that ready. But yeah, we're just gonna be introducing how to create these graphs and and how to customize them so they look professional for your actual research posters. Then we're going to go into data analysis. So we're going to show different techniques to analyze your data and how to interpret your graphs. And then we're going to do a small activity with that. And then we'll introduce the conclusion. And then if we have time at the end, we will try to get started on the poster templates. But if we don't, then we'll push that to for tomorrow. And then obviously we'll end with the Kahoot.
Yeah, okay. So for data collection, let's just talk about graphs real quick. So I'm sure most of you already know, what a graph is. But there is a difference between what makes a good graph versus a bad graph. So as you can see, the good graph, it has a very clear title of plant height over time. You have labeled axes with units. You have on the y-axis, you have the height in that is centimeters, yes. And then on the x-axis, that's days. You have the right graph type, which is a line graph, and it's also very easy to read. It's very straightforward. You don't have to, guess about anything. Meanwhile, for the bad graph, there are no axes labels, as you can see on the x and y axes. It's a very vague title. It's just results, which doesn't tell you anything about exactly what results they are. The scale can mislead because you don't have a y-axis there to tell you the difference between group A, group B, and group C. And overall, it's just very hard to interpret. Next slide, please. So for your graph, this is like a pretty good checklist to follow. So, your title should tell the reader what the graph is showing. The x-axis and y-axis labels, they should be labeled pretty clearly, and they always should include units in parentheses. You should have equal spacing on the axes, no weird jumps. You shouldn't have like 1 to be this tall and then 2 to 3 be like this tall. You should also have the right graph type. Bar is for categories, lines are for change over time, scatter plots is for relationships. We'll go into that more in depth with later slides, but yeah. The scale should also be fair and start at 0, especially for bar graphs, unless you explain why not. There should also be a legend if there are multiple lines slash groups, different colors, and So for different, if you have multiple line graphs in one, graph, you should always have them labeled to make it clear which results they're representing. You should also have one clean message. Try to avoid, 3D and extra decoration. It looks pretty, but it's actually makes it very convoluted and harder for judges to understand. And you should also have a caption, which is one sentence explaining the main takeaway. Okay, now we're going to do a mini activity. So, based on the data and the question, just type in chat what you think is the best graph type. So for the data, it's plant height measured once per day for 5 days. And the question is, which graph best shows change over time? So if you guys want to put that in chat really quick. Okay, good, good, good. You guys are all getting it correct, which is fantastic. So, the correct answer is B for the line graph. And this is because, plant growth is continuous. The plant doesn't reset every day. It grows between the days we measure it. So the line helps us see the rate of growth. And just for clarification for A, why it's wrong, the bar graph makes the days feels like separate, unrelated categories. And so what you would use it for instead is possibly comparing the final height of different types of plants for like, different flowers, a sunflower versus tulip, and then comparing those for each of the days. And C would be wrong because, a scatter plot shows the dots, but it doesn't emphasize like the flow of time as well as the line does. So instead you would use it to measure, if you had been experimenting on 50 different plants at once, then you would use a scatter plot to see if there's a general trend between age and height. Okay, and then this one, the data is time taken for sugar to completely dissolve in various temperature waters. And the question is, how does water temperature affect the time for sugar to dissolve? So if you guys want to see what the best answer would be. Okay, some mixed answers. Kind of split half and half between C and A. Wait for a few more answers. Okay, you guys are getting it. So the correct answer is A. And so in a lot in temperature is treated as a category. So you can have
Wait,
multiple.
sorry, I would just
Oh,
like to jump in. For the
okay.
for the label of the axis, I think it's supposed to say temperature. I think that was on us, yeah.
Yeah, the labels on the graph is like slightly off, but
Okay,
that's
yeah, but
okay.
yeah, it's just supposed to be temperature, and then in Celsius you should put like the units. But yeah, the actual graph is what matters. So yeah.
Yeah, the actual like shape of the graph. So for graph A, as you instead of like days 1, 2, 3, 4, 5, you would have categories of temperature, like maybe 70 degrees, 80 degrees, 90, things like that. So bar graphs are really really great for comparing these distinct groups. And so a lot of you were saying C. So C is wrong because without a trend line, individual dots can be really harder to compare at a glance. Also, you're not comparing like a trend of growth here. You're taking like the time, time taken for sugar to dissolve, which can't really be represented by a scatter plot. Screen time and sleep duration each day for each student is the data that's being collected. And the question is there a relationship between daily screen time and hours of sleep in middle and high school students? So you guys should get this based on the keyword. Okay, very good. I'm seeing lots of C's. Perfect. That's the right answer. So you have two different variables, hours of screen time and then hours of sleep. And you see if, these dots from the different data that you're collecting from these different students is forming a relationship between the two. So that would be the right answer. Okay, and so now we'll go into the actual different types of graphs. So the line graph is, the most common visual. It is easy to read and understand, also really easy to analyze. And you have a very direct sort of dependent variable versus independent variable. You have like a y versus x. you can have multiple dependent variables, which are, seen as the different colored lines. And so this is where you would need to color code and have a legend for your graph. So, for an example, you would have like plant height in centimeters, which would be on the y-axis, versus amount watered, which would be on the x-axis. Oh, actually, if you could go back, I do want to give an engineering example because I know if quite a few students are doing engineering projects. So, for example, if you're building something like a remote controlled car, you can graph how the battery voltage like decreases the longer the motor runs. And you can compare and if you want to do, if you're testing different batteries or different motors, then you would have different lines for that. Um, would a confusion matrix be counted as a graph? Not traditionally. I will say I'm not the best suited to answer that question because I don't have experience with confusion matrix, but maybe somebody else can answer that question.
Yeah, wait. I have used a confusion matrix. I think if you are doing, I think you're trying to do like an AI or ML type of project. I think a confusion matrix would be a great, um, I think visual aid for judges especially. You can just throw that into your data analysis section, or sorry, your data section, and keep it as like a small part of it, because the main like body in your data should just be the graphs and then the other things like that. But a confusion matrix would just be like a good aid to help guide them. So I think yeah, you could definitely consider it as a graph.
Awesome, thank you. And then the next one for oh, next yeah, thank you. So for pi and column graphs, these are also, super to read and understand and analyze. A lot of you have probably seen these in your math textbooks. But the main goal of these is to show different proportions of data. So it really shows how different quantities relate relatively to one another. So for example, you would use a pie or column graph to show the percentage breakdown of ethnicities in a high school. Um, and then, for as an engineering example, you would be comparing possibly like especially for a column graph, you could compare like the load capacity of a truss bridge, an arch bridge, and a beam drip bridge, different types of bridges to see which one holds the most weight. And for pie graphs, you could see if you're building a drone of some sort, you could show what percentage of the drone's total weight comes from, the frame, the motors, the battery, the camera, etc. And so those would be kind of like engineering examples for that.
Another, I guess, broader example for most actually ASEF projects would be like a cost breakdown. So, judges are also kind of interested to see like how much money you actually spent on your project and to what you spent it on. I think adding like a small pie chart in your data section, just saying, this was the cost breakdown. I spent this much money on this much money on that. They'll kind of get an idea on what you allotted most of your resources towards. And I think that'll also benefit your project.
Awesome. And then for an area graph, so this is a more complicated type of graph that's sometimes a little harder to understand, but essentially oh my God, it displays how a quantity changes over time or across categories. It really emphasizes, magnitude and trend, not just individual data points. So the shaded area represents the cumulative value, and this is really useful for showing growth, decline, or overall contribution. And so this is, you would use this type of graph when the order of data really matters, like, time, increasing pressure, things like that. It's kind of, you can think of it kind of like a line graph that's filled in to show volume. Yeah.
Okay, cool. I think that now moves us to our activity for today, which is actually creating the graphs. So we're gonna create some breakout rooms and we're gonna guide you through the process of actually creating some of the graphs we talked about.